If you've ever sent a transaction on Ethereum and been surprised by the cost, you've already encountered gas fees. They're one of the most complained about aspects of blockchain usage, and also one of the least understood. Most people know gas fees go up and down. Fewer understand why, or what determines whether their transaction gets included in the next block or waits for 20 minutes. In 2026, the picture looks significantly different from 2 years ago. Average Ethereum mainnet fees have dropped by around 94% since their peak, largely due to 2 infrastructure upgrades. But understanding why fees exist in the first place and how to work with them rather than against them is still essential for anyone building or transacting on-chain. Why gas fees exist? Every operation on a blockchain requires computation, storing data, executing smart contract logic, transferring tokens. All of it consumes processing resources from the nodes validating the network. Gas is the unit that measures how much computation a transaction requires. A simple ETH transfer uses 21,000 gas units, a fixed amount, because the operation is always the same. A complex DeFi transaction, swapping tokens across multiple pools, for example, might consume 200,000 to 500,000 gas units or more, depending on how many operations the smart contract executes. The more complex the logic, the more gas it uses. Gas fees exist because without them, anyone could spam the network with computationally expensive transactions at no cost. Fees create an economic cost for using block space, which limits spam and compensates the validators who do the actual work of securing the network. How fees are calculated. EIP 1559. Before 2021, Ethereum used a simple auction model. Users set a gas price they were willing to pay, miners picked the highest bidders, and everyone else waited. The result was high volatility and poor predictability. During busy periods, users routinely overbid significantly just to get included. EIP 1559, implemented in August 2021, redesigned the fee market fundamentally. The total fee you pay is now the sum of 2 components, a base fee and a priority fee .c #, plus 1. The base fee is set automatically by the protocol based on how full the previous block was. If blocks are consistently over 50% full, the base fee increases. If they're under 50% full, it decreases. The adjustment happens every block, so the base fee tracks network congestion in near real time. Critically, the base fee is burned. It's removed from circulation permanently, not paid to validators. This is the mechanism behind Ethereum's deflationary pressure. The priority fee, also called a tip, is set by the user and paid directly to the validator who includes your transaction. This is how you signal urgency. If you're happy to wait, a minimal tip works. If you need inclusion in the next block, you pay more. Your wallet also lets you set a max fee, the absolute maximum you're willing to pay per gas unit. The actual amount charged is the base fee plus your tip, capped at this maximum. Any difference between your max fee and the actual fee is refunded. In practice, modern wallets estimate the base fee and suggest appropriate tips automatically. For most transactions, you don't need to set these manually. Where Ethereum fees stand in 2026. The numbers tell the story of what infrastructure upgrades can do. In early 2024, average gas prices on Ethereum were running around 72 GWEI. After the Dencun upgrade in March 2024, which dramatically reduced the cost of posting data from Layer 2 rollups to Ethereum mainnet, prices fell to around 2.7 GWEI by early 2025. That's a 94% reduction. As of early 2026, average Ethereum mainnet gas sits around 0.037 to 3 GWEI depending on congestion, and a basic ETH transfer costs between 20 cents and 67 cents. During off-peak hours, it's often lower. During high-activity events, major NFT mints, token launches, DeFi liquidation cascades, it can spike significantly above those levels. Coin law. Daily gas fees paid to the network fell from a peak of $23 million to to around $6.3 million in 2025, which reflects both the fee reduction from Dencun and the shift of transaction volume to Layer 2 networks. Gas on other chains. Ethereum mainnet isn't the only game in town, and the fee comparison matters. Solana processes transactions at fees of roughly $0.00025 per transaction under normal conditions. Its architecture is fundamentally different from Ethereum's, a single global state machine with parallel transaction processing, which allows this level of throughput without the same congestion dynamics. BNB chain sits in the middle. Fees are typically a few cents, significantly cheaper than Ethereum mainnet but more expensive than Solana. It trades some decentralization for throughput. Layer 2 networks on Ethereum, Arbitrum, Optimism, Base, ZK-SYNC, now process between 58% and 65% of total Ethereum transaction volume, handling over 1.9 million daily transactions collectively. On these networks, typical transaction fees run below 3 cents, often well below 1 cent. SQmagazine.co. How Layer 2 reduces fees. Layer 2 rollups achieve low fees through a single core mechanism, batching. Instead of each transaction posting individually to Ethereum mainnet, hundreds or thousands of transactions are bundled together and submitted as a single compressed data package. The Ethereum mainnet fee gets spread across all transactions in the batch, reducing the per-transaction cost dramatically. Rob the coins. The Dencun upgrade introduced a dedicated data storage space called blob space for rollup data, replacing the more expensive call data that rollups previously used. This is the direct cause of the 94% fee reduction on Layer 2 networks that followed. Arbitrum and Optimism use optimistic rollup architecture. Transactions are assumed valid by default, with a challenge window for fraud proofs. ZK-SYNC and StarkNet use zero-knowledge proofs to cryptographically verify transaction batches, which provides faster finality at the cost of more computational overhead for proof generation. Both approaches deliver transaction fees well below 1 cent under normal conditions. Trust Wallet. Practical optimization strategies. Time your transactions. Gas fees follow predictable daily and weekly patterns. Ethereum mainnet is cheapest on weekends and during late-night U.S. Eastern hours, roughly 1 a.m. to 7 a.m., when U.S. and European activity is lowest. Scheduling non-urgent transactions during these windows can reduce costs by 20 to 40%. Use the right network. For most DeFi, NFT, and trading activity, there's no technical reason to use Ethereum mainnet over a Layer 2 in 2026. Arbitrum and Base have broad dApp ecosystems. ZK-SYNC and Optimism are maturing quickly. If cost matters, transact where fees are low and bridge assets back to mainnet only when necessary. OSL. Set your max fee manually for non-urgent transactions. MetaMask and most wallets let you switch to custom gas settings. Setting a lower max fee means you'll pay less. Your transaction will wait for a block where the base fee drops to your specified level. For transactions that can wait an hour or two, this often results in meaningful savings. Watch gas trackers. Etherscan's gas tracker and sites like Gas Now show real-time and historical base fees, which lets you spot low-fee windows before submitting. Some wallets integrate this directly and surface alerts when fees drop below a threshold you set. For developers, gas optimization in smart contracts follows distinct principles. Minimize storage writes, which are the most expensive operation. Use mappings instead of arrays where possible. Pack variables into single storage slots. Avoid loops that scale with unbounded input, and use events instead of storage for data that only needs to be readable off-chain. Batching multiple operations into a single transaction also reduces overhead when your architecture allows it. What's ahead? The Ethereum roadmap includes further fee reduction through Pectra and subsequent upgrades, with particular focus on increasing blob capacity further, which directly reduces Layer 2 settlement costs. The directional trend is clear. Mainnet fees as a limiting factor for end users are less relevant than they were in 2022 and will continue declining as the Layer 2 ecosystem matures. The fee model that once priced out smaller transactions and frustrated new users is no longer the same constraint it was. The infrastructure exists to transact on Ethereum cheaply. The main optimization task in 2026 is knowing which layer to use for which purpose.